topic of chapter 1 is functions and lines. So first section, we are starting with functions. The definition of a function is a rule that assigns to each number from one set exactly one number in another set. So it's a relationship between two quantities with the extra condition that one thing from the first set is paired with exactly one thing from the second set. I like to think of functions like a vending machine. You press one button on a vending machine, you get one snack out. So I push one button, I get one snack. That is a function type of relationship. If I were to press C2 and it gave me Skittles and chips, which doesn't happen, that would not be a function. So a relationship between two quantities, an example as just y equals 2x, that tells me that y is twice as much as x. So I've got the relationship between those two values. We generally use x as our independent variable. So that is a number from our domain. And we usually use y for our dependent variable. So what I get for y depends on my choice of x. So I can choose any number that's in the domain that I want for x. And my calculation for y is going to depend on what I chose for x. Domain can be any quantities that make sense for the problem. So anything that would give me an answer that makes sense for y. So if I'm talking about just this equation that I have here, I could choose any real number for x and I would get a real number for y. If I were maybe talking about a situation where I am walking a certain number of miles and x were representing the number of miles that I was walking, it would only make sense in that situation for x to be a positive number. I couldn't go back in time and walk a negative amount of steps. Well, let's look at an example with some context. In this example, Mr. Riggs consults for a trailer manufacturing company. His fee is $300 for miscellaneous expenses plus $50 per hour. What is the domain of this function? So the total amount of money that Mr. Riggs is charging is going to depend on the number of hours that he's working. So the domain would be the number of hours that he works. That is the independent variable. And then the range would be the total fee that he's charging. That depends on the number of hours worked. So we could write the rule here that this function is giving. Here the domain is the number of hours that Mr. Riggs works. And it would make sense to say that that has to be a positive number. So the domain here would be positive numbers. And an equation that would represent this situation would be the total fee of y is equal to $50 per hour. So 50 times x plus the $300 that he charges for the miscellaneous expenses. So he's always going to charge at least $300. So our range here, or possible values for y, would be at least 300. So 300 and more. So 300 to infinity. We're not going to get anything less than $300 here for the fee. Notice that this is a function. There is exactly one fee for each number of hours worked. So if I plug in a different number of hours being worked, I will get exactly one fee to correspond with that. So every x gets exactly one y. Next, let's practice evaluating functions. So if we are given a function rule or something like f of x, and here f of x is function notation. So f is the name of the function, x is the input. So, and f of x is the same as y. So this f of x equals negative 7x plus 22 means the same thing as y equals negative 7x plus 22. We're just using a fancier function notation. So to evaluate this function, we're changing the value of x, and we are trying to find the value of the function. So f of 2 indicates that now x is equal to 2. So we need to replace the x with 2. So f of 2 would be negative 7 times 2 plus 22. So the x in the original function definition is replaced with a 2, and then we just need to simplify this or evaluate this using our order of operations, doing the multiplication first, and that gives us that f of 2 is equal to 8. And we would find f of -1 the same way, but now our x is -1. So we're replacing the x in the original function with a -1. So -7 times -1. And always when you're plugging in, put it in parentheses. It's better to have some parentheses that you don't need than to need them and not have them. So this -7 times -1 would be +7 plus 22. So f of -1 equals 29. Now for this last part of the question, to find f of 2 plus f of 1, we've already done most of the work. We know f of 2 is equal to 8, and we know f of -1 is 29. So we just need to add them together. F of 2 is 8, f of -1 is 29, so we're just adding 8 plus 29, which is 37. We're evaluating the function, you're just plugging in, changing the input, plugging that in for x. So whether it's a number like we saw here, whether it's another variable or an expression, so something like a plus 2, whatever it is, just put it in place of x and then simplify as much as you can. All right, one last example. Here, Professor Pinkert gives a physics test consisting of 25 questions. A student's grade is determined by the function g of x equals 3x plus 25, where x is the number of correct answers and g of x is the student's grade. Antonio answers 15 questions correctly. What is his grade? So the information that they're giving us in this first part of the problem is the number of correct answers that Antonio gave. So correct answers is represented in the function by x. So they are telling me that x is equal to 15. So we need to plug in 15 for x. So this is going to become 3 times 15 plus 25. And 3 times 15 is 45. So 45 plus 25 means Antonio's grade is 70. Answers 15 questions correctly. Input is 15. I plug in 15 and I get out 70. In the second part, they're asking how many questions Belinda needs to answer correctly to receive a grade of 88. So this time they're telling me the grade and they're asking me to find the number of correct answers that she needs. So they are telling me y or g of x and they're asking me for x. So we want g of x to be 88. So I'm going to replace that whole side of the equation with 88. And then I need to figure out what value for x would make this true. So we're solving this equation for x, trying to get x by itself. So we're going to start moving things away from the x on the right side of the equation. We'll do our addition and subtraction first, and then do multiplication and division. So first I'm going to subtract the 25. 63 equals 3x. I want the x by itself. So now the problem is that it's multiplied by 3, so I need to undo the multiplication and divide both sides by 3. That's going to give me 63 divided 3 is 21. So the number of correct answers would have to be 21. She needs to answer 21 questions correctly to get a score of 88.